Okay, let's see how we're doing. Tell me what you plugged into the normal CDF for the sample proportion less than 75. Less than 75. What are you plugging in here? Here we go. Hey, 11, what are you plugging in? Less than 75. So what's your lower bound? E99. Upper bound? 0.75. Mean? 0.82. And then, yep, standard deviation, 0.054. And Emily, what are you getting out of there? About to the near, yep, it says nearest tenth, so. Yep, that's what I'm looking for. 9.7%. Okay. Everyone all good? All right, what about the other one? Greater than 95%. This one should be a small one. Greater than 95%. Hey, 4, what do we got? Yep. 0.952. Yep, along with 0.82 and 0.54. And you end up with percent of what? 0.8%. Yep, very small chance that we'll get most 95% of the population above the 50%. Everyone all right? All right, finding those, that these sample proportions follow the normal curve. All right. Okay, we're almost there. Go ahead. Let you guys read through about the new common social network app that we're trying to produce. So they're only going to start this app if at least 50% of the student body are going to use it. Okay, only about 50% use it, then we'll start the app. Here we go. What's the sample proportion for this survey? So here, again, let me remind you what sample proportion is. Matt goes out, surveys 30, he comes back with his results. Alex goes out, surveys 30, comes back with his results. All right, so based on this one right here, how many did they go out and survey? How many did they go out and survey? 40, right? And out of those 40, how many said they'd use it 50% of the time? 18. So 18 out of 40 is what you're called your sample population, what you went out and surveyed. And since it's a sample proportion, let me know 0.45. Now, they said they're only going to make the app if 50% use it. So they got 45%. But as we know here, and you guys have been drilled, is one good enough? Never. You can't just say, oh, only 45%, that's it, scrap it. Let's get out of here. Well, what about everybody else? All right, everybody else, we're not going to get to everybody else. So we got to do, as usual, a simulation. All right, we're going to do a simulation of 200 surveys of 40 students. And this is what we found out with the dot plot. You can't just go by that one alone. We got to do more. So we did 200 more. So what I want to know right now, and this is good review for tomorrow, margin of error and confidence interval. Let's review right now how to find those. All right, let's review. First, margin of error. Look back if you need to look back. How do I find the margin of error? When you have it, let me know, 5. When you have it, let me know. Margin of error. Because we're going to review this once again tomorrow. Thank you. Plus or minus 2 times my standard deviation. I will provide you with the standard deviation for this one. Here you go. The standard deviation, guys, for this one was 0.047. And because I know you're going to need it coming up, the mean was 0.501. So plus or minus 2 Standard deviation, 0.047. What is my margin of error? Plus or minus what? Here you go. Not here. 5 again. Here we go. Sorry, Patrick. Thank you. 0.094. No decimals. 0.094. Okay, so there's the margin of error. Do you remember how to find my 95% confidence level? Anybody remember that formula? Go back again, look. I don't want to give it to you. This is a good way to review. How do you find the confidence interval, specifically 95% confidence interval? 13? Hello, Vinny. Okay, so here you go. What was the mean for this one? 0.501 plus or minus margin of error we found was? Yep. Okay, so I'll let you guys go ahead. 0.501 minus 0.094, and then add them together to find my 95% confidence interval. What do you got for me, 17? Yep. Yep. Okay, here's how we're going to answer the question now. Is there evidence from the simulation and from our population, the 0.45, that 50% will use the app? Ready? Here's what we just found. Ready? We are 95% confident that 40% to 59% are going to use the app. That's what that means. And what did our sample proportion come out to be? What did our sample proportion come out to be? 0.45. Is that within our confidence level that we're 95% confident in? Yes, so that means, yes, we have evidence that it'll be at least 50%. If our sample proportion is within our confidence interval, we can say, yes, there is evidence because 0.45, our sample proportion, falls within our confidence interval. Okay. If your sample proportion falls within your confidence interval, then yes, we are pretty confident that they'll use the app 50% of the time. We okay? Because this might be my most favorite problem coming up of the entire unit. Yes. It's a very simple multiple choice, but it's one of my favorites. Good old Anne's a coin flipper. How about that? She flipped it 100 times and got 73 heads. Wow. And 27 tails. Given the results of her coin flip, which is most accurate? Well, first of all, I got to describe something and I don't assume this because a couple people asked in period 3, what's it mean by a coin not being fair versus fair? Anybody want to explain that to your classmates? Or okay, if a coin's not fair, it may be heads on both sides, tails on both sides. It might be weighted on one side versus the other. Okay, that's what an unfair biased coin is. I don't know if I've never seen one, but that's what they tell me it is, Matt. You know what I'm saying? Okay, a fair coin, heads and tails, weighs the same on both sides. Okay, so which one can she conclude here? Which statement can she conclude the most? Well, hold on. She got how many? And by the way, this is the output of proportion of heads. This dot plot is the proportion of heads. And not that it really has anything to do with the problem, just the ridiculousness of this, what she just did. She flipped 100 times and did that 200 times. So she flipped it 100 times, she got 35% were heads. Flipped it another 100 times, got about 60% heads, and she did that 200 times. How about Ann, huh? Give it up, huh? Okay, never mind. Why do we even bother? I'm going to keep trying all year. I'm going to break you. I'm going to break you. So she did this 200 times, flipped the coin. So somebody, I believe, anybody know Carter? Thinks he's a stud, but not at all. But he did the quick math. What was it? 20,000 flips of the coin. That's what this ended up being. Okay. So what can we say about her coin? Well, how many heads did she get on her own sample? How many? 73, right? Notice anything about our dot plot, guys, when she ran the simulation? What do you notice about 73? It's not even there. That's a little unusual, isn't it? Coming up with that word again, unusual, that 73 comes up. Okay, that's unusual because when we did this thing 20,000 times, 73 never came up. Okay, never came up. So that's a little unusual. So based on these four here, what do you think you can tell me? What can you tell me? All right, 73 never came up in the 200 simulations we did. So what can you tell me about the coin? Yeah. I just want it to come up once. Just once. Just once. Who just went last and answered the question for me? Go ahead, I need somebody then. Matt, what can you tell me about Ann's coin? Yeah, it's probably not fair. Because when I flipped the fair coin, this is what I ended up with. I never got 73. That's highly unusual. All right, good. I'm a little emotional now because this is the last new problem I'll be doing with you guys as far as the Algebra 2 curriculum goes. Savor it in. Oh, and again, no E though, no E. Ha! How about that? No E. Got everyone on that. Different Ann. This one owns this t-shirt printing business. There's a lot to read. I'm not going to do it for you. Go ahead and read it up. Obviously, she's a risk taker, going from 8 to 10 solid color varieties. That's a risk taker. And she's only going to do it if she's 95% confident that 35% of her customers will buy at least one of the two new color choices. So what she did, she went out and surveyed people. I'll ask somebody about her survey in a second. She surveyed 50 people. And then she did a simulation. Does it say how many she did? How many simulations? No, it doesn't matter. But she did her simulations where, take a look, 35% is the mean. She ran her simulation based on 35% would be the mean, and this is what she got. All right. Is there enough evidence that she should go to expansion of 10 or not? Okay. Well, first of all, what's your sample population, sample proportion here? When she went out and did her own survey, what was her sample proportion? Matt, just go. What do you got? No, need somebody. 13 out of 50, which is what, Brooke? 0.26, thank you. So that's what she found. But she's got to be 95% confident. So what do we need to find? What do we call it if we want to be 95% confident? Confidence interval. No, could we look here and say what's going to happen? We kind of already know what's going to happen, right? If we take a look at our simulation and our 0.26, we know what's going to happen here, but let's mathematically show it.